Good morning, everyone. Today, we are going to see on the topic of the types of analytics in the data analytics and automation system. So, I am Karthiyan, working in the Department of Mechatronics Engineering at SNS College of Technology. So, what exactly do we mean by data analytics? Very simply, it is the process of examining the data sets to draw the meaningful conclusion and support the decision making. So, why should engineers, especially those working in automation system, care about this? So, because good analytics gives us the better decision, ability to spot trends and patterns early. So, improve the operation efficiency. That is very important in manufacturing and automation. And yes, competitive advantage in the industry. So, most of the modern automation systems that we see today, whether it's smart factories that will predict maintenance or quality control, rely heavily on or more types of analytics. So, broadly, the analytics world is divided into four progressive types. So, we usually show them like this, like descriptive, what actually happened, diagnostic, why did it happen, and what is likely to happen next, that is comes under predictive, and last one is prescriptive, what should we do about it. So notice this direction, we move from past to present understanding, future actionable recommendation, and as we move right, both complexity and business value increase significantly. So most companies are still strong only in first two. The real competitive edge comes from the last two. So let's start with the most common and most basic type, that is descriptive analytics. This answers what happened. We take historical data and summarize it. So typical techniques like simple aggregation, the like sums, average, counts, like data mining to find the interesting subgroups, and lot of visualization like bar charts, dashboards, trend lines. So a real example you see every day is monthly sales report, customer demographic profile, that is age, region, product preference, and overall equipment effectiveness, that is OEE, dashboard in a factory. So in automation, think of the SCADA or MES system screen that shows last 24 production, like 14,872 units, downtime of 47 minutes. So this will clearly give. Now we can go one level deeper, like a diagnostic analysis and why did it happen. So here we are not satisfied with the numbers. We want the root causes. So the common technique is drill down, that is from company, plant, line, mission, that is correlation analysis, pattern recognition, and anomaly detection. So for example, we can take, why did line 3 stop for 2 hours last Tuesday? So the root cause analysis shows compressor overheating due to clogged filter. So why is rejection rate suddenly high in welding station? So the diagnostic shows voltage fluctuation between the time 2 to 4 p.m. So in automation system, analytics is heavily used in the fault diagnosis, troubleshooting, and failure mode analysis. So here comes the next is the predictive analysis. So now we look into the future. What will happen? So we use the statistical model like times series forecasting, regression, and increasingly machine learning algorithms. So the key activities that we are going to follow in the predictive analysis is forecasting, trend and seasonality analysis, and predictive modeling. So very relevant examples in our domain is predictive maintenance. So this motor bearing will fail with 87% probability next 18 days. So demand prediction for just in time production. So customer churn prediction in a product as a service model. Then quality protection. This batch has 92% chance of failing in the final inspection. This is where most industry 4.0 value starts appearing. And finally, we comes to the prescriptive analysis, the most advanced and most valuable type. What should we do? Oh, it combines the insights from the previous three types. plus optimization algorithm plus simulation to given the action recommendation. So the typical techniques what we are going to use is the mathematical optimization like linear, integer, and genetic algorithm, and also the decision models. What if scenario analysis? So practical examples we can see. So which machine should be scheduled for maintenance this weekend to minimize the production loss? So how to reallocate the robots and workers when one CNC suddenly goes down? Like personalized marketing offers in e-commerce, but also in B2B, which customer gets priority delivery when logistic is constrained, and a supply chain rerouting when a port is blocked. So in automation, systems are starting to appear in the autonomous production scheduling, energy optimization, and the closed loop quality control. So let me quickly show you the mind map view and see the captures the progressive quite nicely. So we start from the descriptive past summary, that is the diagnostic root causes, and predict what comes next, and finally recommend the best actions. So each level is built on the previous one. You cannot do meaningful prescriptive analytics without good predictive, diagnostic, and descriptive layers underneath. So the one-line summary of each is that descriptive is nothing but the historical summary, that is what happened, and the diagnostic is the understanding of the root cause problem, that is why it is happened, and future probability and what will likely going to happen, and prescriptive decision recommendation what we should do, and again the complexity and business value increases as we move, right? So to conclude, understanding all four types helps us become better engineers and better decision makers, not just report generators. So these concepts are used everywhere, like healthcare, finance, retail, and of course manufacturing and automation, predictive maintenance in smart energy management, quality 4.2, etc. So looking ahead, AI and large scale machine learning are pushing the predictive and prescriptive layers much faster than before. So in the upcoming 5 to 7 years, we will see many more autonomous decision systems in the factories. That's it all for today. Thank you.